3, 2.
So, hi everyone. Today we'll begin the podcast with Jyoti Kumar. He is also our senior from IT Kharagpur. Jyoti has over 20 years experience in geophysics. Today he'll be walking us through some seismic problem challenges he's dealing with, and let's start the discussion with him. Thanks, Jyoti, for coming to the podcast and accepting our invite.
Thank you, Tanista, for having me. Yeah.
No problem. So Jyoti, maybe we can start with your you have a lot of experience, so maybe we can start some seismic problem challenges you face, your day-to-day work, and then we will go into, maybe you can take some deep dive into some case studies which are really interesting, and we'll go from there.
Sure. Yeah. I mean, I think after getting my degree from IIT Kharagpur, I've been working in seismic industry for almost 20 years, as you said. I have lived in many countries while working. So I started with India, then moved to UK, where I worked for 6 years. And then I have been traveling to Cairo, Malaysia, and then back to Cairo. So I have a huge amount of experience in terms of type of data I have seen and the different challenges I've seen and different type of basically processing. So yeah, I mean, if you have any specific question, I'll dive into that a bit later.
Yeah, sure. Maybe we can talk a little bit about the type of data you see in different fields. What are the challenges?
Right.
If you can just walk us
Yeah,
through that.
so
Like, let's say
basically,
Europe
when
and
I was
Asia, what differences do you see in the data quality and all? What are the
Yeah.
challenges? How do the challenges change one geology to the other?
Yeah, so basically, I mean, of course, as you go around the world, there are lots of different challenges. So, for example, if in India there was challenge about the basalt, sub-basalt imaging was one of the key challenges. Then when you move to in UK, it was a bit different because I was seeing lots of different type of data set from North Sea to West Africa. So of course, in North Sea, the challenges are related to more carbonate and chalk. As you go to the West Africa, it was more salt imaging, subsalt imaging. When I moved to Cairo, its Mediterranean is completely different beast actually. So it's the Messinian layer actually is very complex, and there are lots of heterogeneity, and it's still a challenge actually. It's, even if we have a very high class modern data set we have acquired recently, still it's not very good in terms of imaging the sub Messinian. And now when you go to Malaysia side, in fact, there are lots of gas there. So the geologically, it's not very different in terms of, I mean, velocity variation itself, but there are lots of gas pockets which create lots of imaging issue, sub gas. So yeah, that's kind of variety I have seen overall during my experience. And then of course, when I started, the technology was at different level, and now the technology has advanced a lot. Computing has become much cheaper. So there are lots of things which we couldn't do 20 years ago. Now we are able to do very easily. So there has been lots of advancement in terms of velocity model building, in terms of imaging itself. And yeah, I mean, I've seen actually that it has improved the result a lot, not only in the processing, also in the data, the way we acquire data. So there has been, initially we used to have, I mean, the single sensor recording, which is just hydrophone. So there were lots of bandwidth issue. Now we have got much more broadband data, which means you can actually get more octaves on the lower side, which is much better for imaging or even inversion on many other geophysical purposes, basically. So yeah, I've seen quite a lot of advancement, but still there are lots of rooms to improve further if I want to image where the people wants to see actually the data itself.
Oh, okay. And what are the techniques that are kind of used for cleaning data and just like in a regular basis that you use?
So yeah, there are lots of signal processing techniques. So Fourier still is very popular. So it has been popular 20 years ago. It's still very popular. So that's definitely one of the I mean, technique it's still used. I mean, there are other techniques like, of course, there are lots of migration algorithm, but in terms of denoising itself, yeah, it's mainly the Fourier, then curve-led domain, and then wavelet transform. All the signal processing tools you can think of, we have in place to remove some of this noise, which is unwanted. Now, unwanted actually is a very also, there are lots of energy which we thought actually might not be useful. Now it start to become useful. So it depends actually what you're trying to look, what you're trying to achieve. And sometimes actually some of those energy also can be, used to image and even improve the result further. Some of the example can be, for example, multiple energy. We used to think that is a noise, and we used to remove them actually, but then that also contain quite a lot of subsurface information. So people have started using those energies to get more information about the subsurface. Same with the converter, for example. So that again, we normally used to only deal with the P wave, but because we know the mode also gets converted, which we never took into place. But now those also have information about the subsurface. So why to lose them? So there has been progress also to use those energies to get even better image, especially in the salt area where actually mode conversion happens more frequently. So so there are quite a bit of technique like that which is used to clean the data and also to image to get better picture of subsurface.
So now, like in the seismic processing, are we using multiples to like sort of focus back to the primary and then like sort
so
of adding them?
there has been technique to use multiple to image. So especially in shallow water where, because again, we want to improve our efficiency in acquiring data. So we normally in shallow water, we used to record with much smaller number of cable, because if the larger offset, you don't record the subsurface, shallow subsurface. But now you can in fact record with white too, but then you can use multiple to image the shallow surface where you miss primaries. So there has been lots of advancement there actually. So you can use multiple energy to image especially the shallow part. Deeper part we don't need because primaries are good enough. But in shallow, multiple has been very useful to image the subsurface. Yeah.
And when was this transition happening, like using the noise to map back to
I
the
think
signal?
it has been for last, the technique was there and the theory was there a long time ago, I would say. But I think in practice, it started maybe 8 to 10 years, roughly. So again, as I say, it's not very routinely done, but wherever there is a shallow water and challenges where primary cannot give you the answer, I think multiple has been used quite significantly. And OBN, we always use multiple. We didn't realize, but we always use OBN, which is what we call mirror imaging. So mirror imaging actually nothing but actually use all your multiple space, the first bounce ghost. So it has been used in the past, but only in OBN. Now we started using in most of the data set wherever we have good multiple but not primary.
Okay.
Yeah.
So you mentioned improvements in computation. So what do you see? Like where do you see the improvement? Like is it like faster migration algorithms are converging faster?
Yes.
How is it?
So there has been advancement in terms of the architecture itself. So we had normal CPUs, which then we got GPUs as well.
Yeah.
And then of course stack of things like, but now in last 3 years there's something more transformation happening, because we used to actually in-house manage all the computer, but now with the presence of cloud, now you have limitless computer at your hand. So because of the cloud being there, you can scale up your processing to a many-fold actually, which was not possible before. So that's cloud. Actually, I think cloud computing has been the biggest game changer, I would say, because then you have access to the lots of computer whenever you need, and you can upscale, downscale at any time you want. Before, we had to invest a lot of money in putting the computer in house, and sometimes, let's say, when there's downturn, those computer was doing nothing actually.
Yeah.
So we were losing money in that sense. But now, because with cloud, if I don't have much work, maybe we'll not use any computer. We don't pay anything.
Yeah.
But then when you need a lot, you get actually as much as you want, really. So I think that is the biggest game changer. And then we started using all that algorithm which require huge compute time. It's possible now, but before it was practically we were limited because we have only limited amount of resources to use. So I would say biggest is cloud computing, but then of course the computer itself has improved, right? Before CPU was much it was not as fast that what we have now with advancement of GPU, and now probably TPU will come as well. We are not using TPU right now, but maybe if Google make a great success, then we might be using TPU. So it will again increase times actually with quantum.
Yeah.
So the industry is like fully moving to this cloud computing, or it's a hybrid kind of thing? there is still some computation in-house plus cloud as a hybrid?
Yes, so there is a I would say hybrid, but I would say 80-90% of compute was algorithm, migration algorithm. I think that has already gone to cloud. So it's hybrid, but it's a huge, I mean, weight on the cloud, not on the in-house. In-house is really for doing the testing purpose, where you only require small amount of data, do all the parameter optimization. Once you get the parameter optimization, all the big chunk is happening in the cloud already.
Production is mainly happening on the
Yes,
cloud.
yes,
Testing is happening like with the in-house.
kind of, yes. I mean,
But
still signal processing has not been moved to cloud because they don't require a huge amount of compute. But all the big amount, the algorithm which require lots of compute, like FWI, Fourier full waveform inversion, or all the migration algorithm, all has gone to the cloud already.
but that this data transfer cloud to this like local server, let's say, so the computation time has to be significantly more on the cloud side to
Yes,
justify this migration of the data
correct,
itself, right?
correct. So to give you perspective, actually, it's then, let's say, I mean, a project of size which require 2 weeks of production in-house now can be done overnight or maybe couple of days at max. So this upload and download actually time which it takes, actually it's still much smaller than what we can gain by putting the compute on the cloud. So yeah, I think it has given a lot of room actually for us to do a big projects very easily without managing the
And
compute. Yeah.
this cloud computing, like there are some like famous vendors on this, like how is it
Yes, so I
with that?
think Microsoft Azure is there, then Google Cloud is there. Of course, Doug actually, which is already doing processing as well. They have their own cloud which they offer to others. But I think
DUG,
Google
right? Down under
is
geosolution.
down. Yeah, correct. Yeah. So but I think the most popular one are the three major: the Microsoft, Amazon, and the Google Cloud. They are
It's
the
like
three.
companies take it on lease or something, like, or it's like a membership kind of thing, and whatever you use, you pay for.
I think everybody is doing their own deal. So
Okay.
there's
Yeah.
no, I think there's no specific
Standard.
rule because there are only few people, right, in oil industry who will use that big. So yeah, it's there is a kind of commitment that I will use that much of compute at least, so you get a much cheaper rate that way. But yeah, I mean, it depends. It depends on each deal they have been able to crack, I would say. So you estimate what kind of compute you will use, and then you commit that much, and then they give you a good discount, let's say, on that.
Yeah, of course. Yeah. Yeah, whenever you want to scale up, you can scale up or just
Yeah,
scale
scale
down.
up,
Yeah.
exactly. That's the biggest advantage, I think. And
Yeah.
it's OpEx now. Before it was CapEx, so you had to
Yeah.
invest in capital. But now actually it's whatever you use, you pay
Yeah.
on the go. So it's now
That's right.
operation expense rather than a capital expense. So that's the
Definitely.
difference, biggest difference, I would say, in business.
Yeah, for sure. So, Jyoti,
Yeah.
what do you think about new technologies? I mean, because we deal with more deep learning AI. So, have you seen those applications? Are they doing part of, or are they taking over in some processing areas, or maybe migration? Have you seen this algorithm?
So
Or
yeah, I mean, I think there's a big
mm,
bubble around the deep learning. I would say. Of course, it has a huge merit, but actually, it's not yet been very successful in
mm-hmm.
processing. Yeah,
Okay.
but I think one of the reason I feel actually is that we have to think a little bit because it's so high tech. The fancy word deep learning. We want to apply it everywhere, and I think for
Yeah.
me personally, I feel this is not the right approach. What we
Mm-hmm.
should do actually, we should see actually where actually it can benefit the most.
Yes.
And I think we have seen that is happening. For example, I think where the deep learning really help is if you think about over project life cycle,
Mm-hmm.
then of course now with high compute, as I say, that the big algorithm you can do very quickly anyway. So I don't see a
Mm-hmm.
big deep learning advantage there, because that's what deep learning is trying to do, is making it efficient. So
Yeah.
whatever is taking time, you can do it faster. But if already physics based method is doing things faster because of the compute
Mm-hmm.
being cheaper and available, then there's no point actually, investing there. But what is, we need to invest where we spend a lot of time, but it's not really a geophysics, which is basically a QC, right? So we do lots of
right.
QC, people look at lots of data set all the time, and they spend a lot of time, which probably they will find only 5 or 10% of the problem, but they have to look at everything to find out
Yeah.
that 5 to 10% of the problem. So I think if deep learning, that's where it will be most useful. So if deep learning can learn how the people do the QC, and then they can track down that, okay, this is the 3 million traces you have got, but you only need to see this 20,000 where I am not sure whether things have gone well or not. So then actually this geophysics now need to go there and then look at this and interpret whether whatever actually machine learning has pointed, is it really I can pass or I can't pass. I mean, we have to do something different. That there we have a huge value. So I think that's where I think my organization, and I think others are also working on, to come up with an automatic QC. We have also come up with a technique which is, we were talking about denoise earlier, of the biggest FX filter, and they are the biggest still used technique. But then we also used, what we try to do actually is, instead of a user trying to understand and do the testing in terms of parameter, what the machine learning can do actually, it can identify where my data is more noisy, where my data is less noisy, and automatically come up with a parameter, rather than user trying to come up with a parameter which works everywhere, which doesn't happen actually. So we always have to do compromise. But that's where machine learning I see a value. And I have seen personally, when we implemented this technique there, we have got much more efficient way of running denoise, right? So now user don't have to spend a lot of time in testing, and 90% of the noise is removed without any parameter testing, basically. But it's more like classifying that this is the noise and this is not a noise. It's still the method used in this technique is FX filter, but FX filter with the right parameter, depending on what kind of noise it has detected, how much amount of noise is detected, and parameter is automatically optimized that way. So this kind application like that, I feel, may be much more successful, where you use machine learning to identify things, but then use science to remove it properly, rather than if you do a magic like, okay, this is the input and this is output which is clean. That I think will not work easily. It can work, I'm not saying that it will not work, but for them you need huge amount of data which you can use for training. And again, that's the biggest challenge also if you want to use a machine learning, because whatever data you have for training, that's what you will train model will be, and it will be biased based on whatever data you have collected. So yeah, that's my personal opinion, that I don't think it can replace big chunk of science, but it can definitely replace where we are spending time. Maybe we just should not spend that much. That so to make actually geophysics do more geophysics, then then the laborious work, let's say. That's where I think
for sure. Automation kind of,
automate kind of QCs, or automate kind of quick estimation of what will be the best parameter for this technique, for example. And then geophysics only do the interpretation. Okay, that looks right. If not, then I will tweak. Otherwise, I'll move on basically to the next.
Okay.
That's my feeling. That's my take on
the testing, some kind of adaptive testing, and in the QC, automatic QC,
automatic QC,
in a hybrid mode, which can reduce even half the time or 1/3 of the time. That can be more valuable. Production, I think.
And I feel the machine learning has been really successful where you have a classification problem, right? Where you want to get exact answers, it's not going to be very successful. But it's when you're trying to classify, saying, okay, this is one type and this is another type, then it works much better. Because I've seen, for example, interpretation actually is like that, right? So in interpretation, it has been very successful because you're trying to track something which is, you're trying to classify basically that, okay, this looks like very similar. And also, for example, salt kind of geobody, if you want to try to identify it, I think it's best suit for that, because salt has a very specific character. So if you have enough data where you can identify, okay, this is the salt body, and around you have lots of reflections, and this is very transparent body, then I think it can really detect very nicely. Maybe not perfectly, because again, salt structure has been sometimes can be very complicated. The interpreter actually struggle many times.
Right, of course.
Yeah, but then machine
Yeah.
learning can at least give you
Give
80,
you
90%
the
solution. And then
and
20%
the rest.
is the
Yeah.
interpreter spend time.
The,
So again, yeah, it's like QC, right? So
Yeah, I
it
think
gives you, it say, okay, don't do 3 million of interpretation, just do 20,000 where you need to really spend time. Not very
so,
easy one. Let me do it.
so the machine learning is also a kind of a machine learning of QC.
Yeah.
Being a geophysicist as a machine, like in
Correct,
movies.
yeah, exactly. Yes. So yeah,
very
that's what
good.
I feel. I think
Yeah. No, no,
It's
you
good. I think you
so
gave a good classification that there is this the processing, there is a testing, there is a production, there is a QC. So for
yes,
production, it may not be that useful
as
because it's
useful. Yeah,
a very
correct, correct.
manual
mm,
thing. I mean, it's more on the computational part, so AI may not be helpful there. But in the testing part where there's like a lot of human time is involved, so if there can be some training at least, that okay, fine, like
Yeah,
do
yeah.
all
exactly.
this parameter as a automation, like okay,
Yes,
tuck,
yeah,
tuck,
yeah,
okay, instead of like manually putting in, etc. Whereas and the QC the same, like looking at let's say the stack QC only from all directions and making sure that all the continuity is okay from all directions at least. And
all
wherever
directions.
it's
Exactly.
okay, it can flash that okay, fine, check here, check
Yes,
here, check here.
yes,
So then
yes.
the
Wherever is not sure, just flag it,
yeah,
and then
just
it
flag it.
will
Yeah.
only look there. Yeah,
Yeah, yeah.
not everything. Correct.
Kind of a CCTV kind of.
CCTV, yes, yeah. Monitoring system
Okay,
and with
something is
alarm.
happening.
With
Tuck, tuck,
alarm,
tuck.
yes.
Alarm with an alarm. Okay.
Yes, yes, correct.
Uh, that's definitely nice. No, at least you cannot, of course, trust a machine, whatever it's outputting yeah, without. And also there is a challenge like QC for different geophysics will be also different, right? Sometimes.
Yes.
So there's you also need some kind of common ground somewhere. So that maybe machine learning can help.
Correct.
But if
Yes.
yeah, of course it will vary somewhere. No, it's very good. So Jyoti, maybe this the last part of the podcast. It's like because you've been in the industry for so many years. So what's your take on clean energy? Maybe I'll just show it very high level, and you can think where you
Yeah, I
want
mean,
to.
so again, yeah, I think I'll give you my personal again. So basically, the problem is serious. Yes, so there is an environmental issue.
Yeah.
Then people have to do something about it. But saying that oil and gas, I mean, you can remove it from the system is not going to work, basically, because first of all, actually, yes, there are some green alternative, but then we have not yet find the solution which is completely green.
Hmm.
That's maybe I should take that as a, but maybe it's less or more cleaner than oil and gas. But there are so many other advantage of oil and gas because they are, I mean, if you think about even the, let's say what are the other alternatives? So we have a nuclear, but people don't want to use it. I think nuclear probably is the better alternative, but of course we have a nuclear waste issue and there's a risk actually with that as well. But then we have a wind farm or the wind energy, then we have a solar energy. And I totally agree actually that they can replace, but then amount of electricity they can produce is not yet at the scale we need. Yeah, world needs are still increasing. It's not like we have stabilized our need. The needs are
Mm,
still increasing every time. And there was a model I have seen where the if we estimate how much world need electricity, let's say in 2050, and how much we can generate from the renewable, then still the oil and gas need actually is going to increase, not as significantly, but it's not going to decrease, for example. At least it will either stagnate or it will increase. There is no way
mm,
actually we can say that we need less oil and gas in next 20, 30 years at least.
mm,
So, but yes, I totally, and I think also align that we need to do something because environmental effect is very strong, which actually is a serious issue for human. So there are effect. I mean, there are also effort in terms of carbon storage and capture
mm,
storage, where again oil and gas industry is helping, and I think
mm,
that probably required some willingness where people can invest because of course when we talk about CCS, it's really investment. There is no revenue coming from it.
mm,
So that's where people needs to think, oil and gas industry needs to think actually maybe if we are, because we need oil and gas, we can't shut it down, but at
mm,
least we can capture the carbon we are producing and put it somewhere safely, because we know this technology, right? Where we take the reservoir out, we put something down there, so we know how to put safely in the reservoir, in the rock. So that definitely can help to clean while we are transitioning to a, let's say, completely renewable in 30-40 years time, if it's ever going to happen. And yeah, so that's what I feel. So, I mean, there is a oil and gas is not going to go anywhere, and there's so much advantage with oil and gas that it is much easier to transport. It's much easier to process and get energy quickly, right? And other thing that will require so much of infrastructure built up that it's lots of money which needs to be invested. I was doing a study because I did MBA recently, and one of my thesis was the offshore wind farm, and I tried to study that actually, and it was very interesting that when you start thinking about offshore wind farm, it will only be producing electricity 10-15 years from now. So if many governments are starting thinking about now being renewable and try to invest in offshore wind farm, for example, it will take them 10-15 years before they can actually produce even first electricity. So all this, while that is happening, you still need energy. Yeah. So from where that energy will come from? And there is only one oil and gas probably. Now everything gets electrified. Okay, maybe oil requirement go down, but gas is still needed because that's still a biggest source of energy to produce electricity. Because you need electricity, and you don't, coal is not clean, and we still use coal to produce electricity. And we are saying everything is electrified, and we will not need it will become green, but it's not, because source of electricity is not green yet. Right? That just also needs to be changed. And that's why I'm saying, if we go to offshore wind farm or solar, first of all, there is a waste problem, which still we have not figured it out. But also, in order to produce first electricity, it requires time, 10-15 years of development of the infrastructure itself. So yeah, I mean, I don't think the oil and gas will be still very, very important part of the energy mix for maybe, I would say, 20-30, or maybe more, actually 40 years from now. But maybe we need to move. I think I'm really with energy transition. We need to transit, but it's not going to happen as we're dreaming right now. So it's not going to happen that quickly. So we still need oil and gas, and probably this industry will help actually also. Like, for example, my industry also trying to invest. As I said, we are doing lots of carbon storage project with the whoever is willing to invest. And then we are also doing one of the department is doing offshore wind farm, because when you do the development, you still need to know the geology where you're going to put the infrastructure. So there also seismic is useful to find out where there is a high risk or low risk to put the infrastructure in place. So yeah, I mean, and then I would say, again, my dream would be that hydrogen energy becomes successful, because that's probably is the game changer. When we will have the hydrogen energy, then probably I will say it might transition becomes a little bit more faster, because that can produce a lot of more energy than any other, and it's more clean as well, to be honest. Yeah. So yeah, that's my take. Maybe too long I took, but
No. That's completely fine. No, that's what we wanted to know. Like, everyone has different opinions,
correct.
but
Yes.
it's very insightful. Thanks, Jyoti. So I think with this we did have a lot of discussion, and it was a very nice podcast. Thanks, Jyoti, for your insights. Of course, your 20 years experience is so much. It
No
cannot be
problem.
covered in 20 minutes, of course, but thanks for sharing the knowledge.
Thank you for having me as well. Yeah, thank you.
Thank you.
Thank you.